am back with a new video. In this video, we will gonna discussing about RC phase shift and Wayne bridge oscillator. In this video, I will gonna covering RC phase shift oscillator. In the next video, you will see Wayne bridge oscillator. So here, let's take this RC phase shift oscillator, which is a lab experiment for 4th semester ECE students. So let's get started. Let's define our aim to design RC phase shift oscillator for the given frequency of oscillation. They will give some required frequency, so that for that frequency we have to design our oscillator, which is a RC phase shift oscillator using R and C components. So let's get started. Basically, as per studies, I will give some introduction about RC phase shift oscillator. So what is an oscillator? Let here you can see what is an oscillator. An oscillator is an electronic circuit that produces periodic oscillations. An electronic oscillator is an electronic circuit that produces periodic, which means which is continuous. It may be a sine wave, square wave, or something like that, which is a periodic, which changes towards constantly with time. This is called as a periodic wave. A sine wave is called as periodic wave. Signal often a sine wave or a square wave, anything may be, but it should be periodic. This type of oscillations which produces such a device or such an electronic instrument is called as an oscillator. I can't say instrument, it is an electronic oscillator is a circuit. Okay. Next is we will discuss about definitely what is an RC phase shift oscillator. So we are concentrating more on RC. What is this RC? RC represents R for resistor and C for capacitor. This oscillator is designed by using only R and C components, and we are using op amp also. So RC phase shift oscillator is a linear electronic oscillator circuit that produces a sine wave output. It also produces sine wave output. It consisting of an inverting amplifier. You may know that this is an amplifier, and it will be an inverting mode. It will be connected to ground and inverting mode is applied, and this is the type of op amp we are using in this RC phase shift oscillator. This RC phase shift is designed by using op amp 741 and a resistor and capacitor in a ladder network. I will explain what is a ladder network. A ladder network is something like this. We see this as an resistors. See, if these are resistors and here it is a capacitor, then this is considered as a ladder network. So it's not mandatory like it should be like this only. It can be in reverse order also. Like in RC phase shift, we will exactly use these capacitors. We will use these capacitors like this, and we will use a resistor so that it will look like a ladder. So these will be grounded. This circuit is called as a ladder network, and of course this is also called as a ladder network. Here we are using R and C. Here also we are using C and R. R and C both are same. Like this we are using. So in this RC phase shift oscillator, what happens is the output voltage leads the input voltage by 90 degree, which means here you may have seen these graphs, voltage graphs and current graphs. There will be a slightly difference. There will be a phase shift of 90 degree. See, like if it is an current and this is voltage, always current or always output voltage, what we are saying, output voltage leads the input voltage by angle less than 90 degrees, which means it should be less than 90 degree. What is the output voltage we are getting? This output voltage is always leads the input voltage by 90 degree. Next we are getting to the circuit diagram, which is very important, so that the circuit I am describing here will surely work. So here we have this circuit. This is a variable resistance and this is wrong. Just use 1k. The value get more perfect at 1.3k if you choose, and use the capacitor of 0.1 microfarad. This is a ladder network. See, you may have seen this is called as a ladder network where C and R are in this fashion, and we are using capacitor of 0.1 microfarad and resistor of 1.3 kilo ohms. So this is will be an inverting amplifier minus plus. This is an inverting configuration and we are using 741. Here is the V0. V0 output we will get something like this oscillations just by giving a DC power supply. So in oscillator, what is the input? What we will give the input is just an DC current, which will be a minus 15 volt or plus 15 power supply, and in output we will get like output of a signal generator. So in the basic question asked in YY is, do you use signal generator in the experiment of oscillator? I said no sir. Why? Because positive power supply and negative power supply, that to DC, and gives an oscillations in the output. So you don't require any type of signal generator in the output. Here we have assumed C1, C2, C3 as 0.1 microfarad and frequency given 500 Hz. It's not mandatory that you have to give 500 Hz and we have to calculate, and we have a special formula F is equal to 1 by 2 pi root 6 RC. This root 6, how this root 6 came is by a phase shift of 60-degree each, because this ladder circuit will give the total phase shift of 180, in which each of the in which each of this will contribute a 60-degree of phase shift. By this the total phase shift will become 180 degrees. So here we have the formula. Here you can see here F is equal to 1 by 2 pi root 6 into RC. They have given F for 500 Hertz or any value. You can, by taking this value, calculate the what is the value of R. This R represent the value of DRB that we are mentioned in the circuit in previous. I will show once again. You will get easily understood. So here we have this DRB value. So here we have this DRB value. We are calculating DRB value by using F is equal to 1 by 2 pi, the formula, by that formula. Let's go there. So here is the formula. Okay, by using this formula, calculate the value of R, which is taking okay, we have given calculate the value of R by taking C is equal to 0.1 microfarad, 0.1 microfarad, something like that. And we have to check for one more value. We know that AV, the voltage gain, is equal to minus DRB by R1. By using this formula, calculate what should be the value of R1, R2, R3, but the same value. For this you need to assume the value of R1. Assume the value of R1. By using this value, you can calculate the what is the value of DRB, or you can just neglect these two formulas and you can keep on. Basically, I will show you. This will be the DRB, assume like this, and this will be DRB, and you have a knob right here, and you have to rotate this one at something like, when I was designing a circuit, I got 50 kilo ohms. At 50 kilo ohms, it was providing a decent oscillations of what I have required design for AV29. But it's not mandatory that you should have get 50. But you having basic knowledge of, you have to rotate the knob so that at some point it will give perfect oscillation, that you have to take down and calculate all the values of resistor here. This is a very easiest experiment that when considered to all other experiment. But the thing is, you have to check for all the working of components, because some of the components may not be working right here. You can see here, sometimes you may be in problem of sometimes you may be problem of op amp is not working, and sometimes DRB may be in problem. Make sure that you check for DRB and you check for op amp. Rest of the RNC component will be alright. Basically this won't get be an error, but these two will definitely make an error. And in output you have to connect it to an CRO. It's a very important one. You have to connect the output to CRO. There will be two pin, and another one you make it ground and connect one. Here you can see the waves coming out at some particular time when DRB gets to matches with the overall circuit values, and it will start giving an perfect oscillation. Not so perfect, but it will give some desired oscillation so that your output will be right. So guys, please subscribe my channel. this will give me more interest to do more some of the videos like this, and so many videos. If you are supporting me, I will do so many videos. Like in future I have planned for projects also. So if you keep on liking and subscribing, I will do all those videos and it will give me more interest to it. Thank you guys, thank you for watching. Thank you.